When you build your software, you write production code that consists of several small pieces. Such a small piece can, for example, be a method. When you write your method, you need to ensure that it works as expected. To do this, you can write a unit test. A unit test is another method that just checks the correctness of your small piece of production code. So you can ensure with the unit test that this unit of production code works as expected. And sometimes you even have more than one unit test for a single piece of production code. Now what you can see, if you are able to test your small piece of production code with your unit tests, you don't require the other units to be done, because you test your unit of production code in isolation to the other units. So unit testing is also powerful when working in a team where you don't have already all the other units of production code available. With the unit test, you can already ensure that your unit works as expected. For the other units in your production code, you should write unit tests as well to ensure that they work also as expected. Now when you look at this picture, you see that the unit tests are just testing the small pieces of production code in isolation. A unit test does not test how the units are working together. But before you deploy your program, you also need to ensure that the units work together as expected. And this is done by writing integration tests. An integration test is like a unit test, a test method, but that test method does not focus on a unit in isolation. Instead, an integration test checks if the units work together as expected. So normally you also write multiple integration tests to ensure that the units integrate well with each other. An integration test looks quite similar to a unit test. You can also use a unit testing framework to write the integration test. In contrast to a unit test, an integration test is accessing, for example, the real database to ensure that everything works with the real components as expected. In a unit test, you don't access the real database. Instead, you try to fake the database for your test, because you just want to focus on the unit that you are testing. You want to focus on an isolated piece of production code. And with this in mind, let's look at the definition of a unit test. A unit test is a small automated test coded by a programmer that verifies whether or not a small piece of production code, a unit, works as expected in isolation. And this in isolation is important, because you don't want your unit test to access the database, your network, or other stuff from the environment. You just want to ensure that the single piece of production code works as expected. To ensure that you only focus on that small piece of production code in isolation, and to ensure that you write effective unit tests, you can use the first mnemonic. Let's look at the first mnemonic now. Effective unit tests are first. The first mnemonic was introduced by Tim Ottinger and his colleagues from Object Mentor. The F in the first mnemonic stands for fast. Your unit tests should be fast to run them frequently. While writing production code, you should be able to run your tests multiple times. So if you run your tests only each half hour, you can write a lot of production code that does not work as expected. So you need to ensure that your unit tests are really fast. The next thing you need to ensure is that your unit tests are independent of each other. You should be able to run your unit tests in parallel or standalone. Also, modifying one test shouldn't affect other tests in your test project. Besides fast and independent, your unit tests should also be repeatable in any environment. You should be able to run your unit tests in the office or on an island where you don't have any network connection. That means your unit test should not access a database, the file system, the network, or anything else that needs a special setup in the environment, like for example an environment variable. The next thing you should care about to write effective unit tests is that the unit tests are self-validating. A unit test should either pass or fail. If you have, for example, a unit test that generates an output file and you have to manually verify if the output is correct, then this unit test is not self-validating. Your unit tests should not require any manual steps to check if the tested piece of production code is correct or not. Instead, the unit test should be self-validating and just be red or green. The last character of the first mnemonic stands for timely. This tells you when you should write your unit tests. You should write them timely to the production code. In the best case, you should write them before the production code. If you write your tests after the production code, you might find it hard to write the test. And maybe you have even written the production code in such a way that it is not testable. So writing the tests before the production code makes sure that you design the production code in a testable way. Alright, so far 5 attributes you need to take care of if you want to write effective and clean unit tests. Now let's look at some unit testing frameworks that are available for .NET before we start writing our first unit tests. To write unit tests, you need a unit testing framework. Now I want to show you 3 popular unit testing frameworks for .NET. The first one is MS Test. It comes with Visual Studio. So if you have Visual Studio installed, you will already have MS Test. Another popular unit testing framework is NUnit. It's a complete rewrite of JUnit for .NET. JUnit is a popular unit testing framework for Java. The third unit testing framework I want to mention is my personal favorite. It's the XUnit framework. XUnit has been written by the original inventor of NUnit version 2. Compared to NUnit and MS Test, XUnit is really lightweight. It doesn't require attributes for several things, like for example, test initialization. It also has several features like parameterized test methods. If I have to create a new test project, I choose XUnit. And XUnit is also the framework that we use in this course. If you are not familiar with any of these testing frameworks, don't worry. I will show you now how to write a test with MS Test and XUnit. So far, you have learned some basics about unit testing. Now let's switch to Visual Studio to write and run a unit test with MS Test. I just got a call from my boss and he wants me to create a math library with a calculator class. So let's create a new project here and let's select the class library. I call this class library ThomasMathLib. Okay. I rename the class 1 that is added by default to calculator. Okay, yes, I want to rename the class as well. And this calculator class should have a public add method that returns the sum of 2 integer values. So it takes 2 values. Alright, for now I just throw a new not implemented exception. Okay. Now I want to write a unit test for this add method. To do this, I can just right click on my solution and say add new project, and then I select under the test category the unit test project. This is one way to create such a unit test project that is using MS Test. But I cancel this add new project dialog here, as I want to show you another approach. Another way to add a unit test project to your solution is to right click the calculator class here and choose Create Unit Tests from the context menu. When I click this, the dialog pops up and it says the test framework is MS Test. Let's create a new test project here. And then it has some templates, how the project should be named, like what's the namespace, and so on and so on. So I just click OK. Now you see I have a new project, Thomas Mathlib Tests. And here I have a calculator test class. And this test class is already decorated with a test class attribute that comes from the namespace Microsoft Visual Studio Test Tools Unit Testing. Let's get rid of the other namespaces we don't use. Okay, now I name the method add should return sum of values. Okay, then here I create a calculator and on the calculator I call the add method and I pass in two values, and then I can use the assert class that comes out of that Microsoft Visual Studio Test Tools Unit Testing namespace, and I use the r=equal method. That method allows me to pass in an expected value and the actual value. So here I expect a value of 5, and then I pass in the result that I got from the add method. To run the test, I can go to the test menu and choose here Run All Tests. I can also go to Windows and open up the Test Explorer. In the Test Explorer, I can also click here on Run All. So let's do this. Now you see, here is our test method and it is red. The test failed because the add method has thrown a not implemented exception. So let's go now to the add method of the calculator and let's just implement that method. Alright, now I open up the Test Explorer again and I run all my tests. And here you see we have now a green test. Okay, so this was a very short introduction into MS Test. Now let's look at how we can write the same unit test by using XUnit.